Okay, so this is 2.2, number 14, which is dealing with something called idempotent elements. Um, so idempotent means if you multiply an element by itself, you actually get the same element back. Okay, so what are the idempotent elements of the group Z plus? Okay, so really what we're asking is, here, let me get some lines here. Lines. Okay, so we're asking, since the operator is plus, we're working in integers. Are there any integers, let's say x, such that x plus x equals x? Well, we can solve this pretty easily. 2x equals x. So if I subtract the x over... By the way, you're not allowed to divide both sides by x. And hopefully you know why. If you divide by x, you're restricting the domain to be non-zero. But 0 is allowable in the integers. So instead you have to subtract the x over. So you get 2x minus x equals 0. So it's x equals 0. And then that's it. That's all you can do. Well, 0 is the idempotent element right there. Okay. Hopefully you can figure that out also just from the equation. You don't have to prove that necessarily. What are the idempotent elements of the non-group Z? And then that's actually usual multiplication right there. Okay. So in this case, we're asking, are there any integers x such that x times x equals x, where this is usual multiplication? Well, that's the same thing as just saying x squared equals x. And if you wanted to solve this, you might be able to just figure it out anyway. But if I solve this out, then we get x equals 0 or x equals 1. And that should make sense. 1 squared is 1, 0 squared is 0. So there are two idempotent elements. Usual multiplication. C is a little different. C says prove a group has exactly one idempotent element. So it turns out that this is not a group, which it says it's not a group. Okay. In fact, you should be able to figure out pretty easily that the idempotent element in a group better be E, right? E star E is going to equal E. And it turns out that you're not going to get anything else multiplied by itself equals itself. So the way that I like to prove this one is not necessarily going to be intuitive for anybody. So that's why I'm making this video, actually. So let's consider this group, right? Star with E here. And then I don't know how many elements I've got. A, B, C, dot, dot, dot. E, A, B, C, dot, dot, dot. All right. Fix this one a little bit. Okay. Well, in any group, E is an idempotent element. So let's fill in the one thing that we can, which is the first row and column. Right? Okay, now we've learned, I'll put this here, since this is a group table, no element can be repeated in any row or column. So if you think about what that means, let me copy this, paste it right over here somewhere. Think about what that means. If I can't repeat anything in a row or column, then that means that this one right here definitely can't be A because A is already repeated. So A star A can't be A. This can't be B because then I'd repeat the B in the row and the column. And B star B can't be B. Same deal with C. Right? So you could just keep going right down this diagonal. You're not allowed to be any of the repeated elements in there. So from this, you can conclude x star x equals x only applies to E in a group. Okay, hope that helps.